Problem 1 asks us to prove that the change in entropy, delta S, is equal to Q over T. Keeping in mind that entropy is defined as K, or the Boltzmann's constant, times log of N. We can think of this problem as a piston filled with an ideal gas under a warm brick. The warm brick will heat the ideal gas to a constant temperature, increasing the volume by delta V. And we can also keep in mind that the thermal energy is equal to the work on a gas plus the heat energy put into the gas. Work being negative PV, we can change our equation to E thermal is equal to Q minus P delta V. Next, we account for how many microstates there's going to be. We know that the number of molecules in the gas is equal to the moles times Avogadro's number, which is 6 times 10 to the power of 23 particles, and V to the power of this number of molecules is directly proportional to the number of microstates, because with a larger space to move in, the molecules produce more microstates, directly proportional to the volume. Next, we calculate the ratio of microstates before and after the expansion, with n final over n initial equal to V to the power of n. We can then say that 1 plus change in V over V to the power of n is equal to n final over n initial. Taking the logarithm of both sides, we satisfy the logarithm approximation equation, which is log of x plus 1 is approximately equal to x for a very large number of x, which in this case volume is. Next, after simplifying the logarithm even further, we get n log 1 plus delta V over V, which we can change it to Q over nkt, since we know that Q is equal to nkt delta V over V. From here, we can satisfy our logarithm approximation equation by approximating the log of 1 plus Q over nkt to be Q over nkt, multiplying by n, the n's cancel out, leaving us with Q over kt. Finally, we can move on to the last step, in which we can go back to our original equation that we defined at the very beginning. Entropy is equal to K log N. Trying to find the difference in this would result in K minus log N final minus K log initial. And we know from this we can simplify this further into K log N final over N initial, which we already know is Q over KT. The K's cancel out, leaving us with QT. This problem is incredibly confusing. On the one hand, it is very simple to go about because all you're dealing with is equation, you're not dealing with any numbers, no math. However, at the same time, you're trying to solve and prove for a concept through a bunch of abstract means. You're trying to solve for equations, you're substituting in different numbers, and there's a lot of places where you can mess up. In my opinion, there is no real way to practice for this sort of thing. It's just something that you have to do. But to understand this problem better, I'd recommend watching everyone else's explainer videos, because this week we have a rare opportunity to which everyone has the same problem. So you can watch literally anyone's explainer video and they can probably explain this to you. And the more videos you watch, the better you'll understand the problem, in my opinion. Anyway, that's all for me for now. Thanks for watching.